world is on the metric system. Most of the math world deals within radians. So depending upon what we're looking at and what you're given, whether or not you are going to be within degrees or with radians. So today our main idea is try to get through as many of the definitions and how radians and degrees interact with one another and going from there. There's not so much today as far as solving for x or any equations or any of that kind of stuff, but what we're going to be doing is a lot of conversions. And we're going to introduce you to the actual unit circle itself and how you create your unit circle in terms of pi with all the reference angles. So let's get started with what are called angles in standard position. Angles, excuse me. Angles in standard position, if you think about what an angle really is, if you guys remember using a protractor, you'd have a flat spot. You guys all remember using these things, right? You put it on the flat spot. It was like this. You draw the line, and then your angle measure would come up here to whatever it was, and you would measure this value here. That's how you were measuring that. What you were doing is you were measuring an angle in standard form, or a standard position, I should say. What you do is the vertex itself basically lies at the origin of an XY grid. Vertex itself lies on an XY grid like that at the vertex. And what they call the initial side is where you would, zero, remember zeroing out your protractor where you started at? On some protractors, you have 0 here on the inside, going all the way over to 180 on the inside. And then on the other side, it was 0 to 180 on the outside. I'm sure you guys have seen that, how it's on both sides like that. It just means depending upon what side you're working your angle from. So in this case, normal human beings always start at 0 on the x-axis out here, and you work your way counterclockwise around the XY grid. So what happens here is your angle measurement itself, you have to have two sides to create an angle. The initial side is the starting point. The starting side, it will always be on the positive values of x. Then the other side rotates into the other quadrants. Now remember, the quadrants themselves are broken down at 90 degrees, because it's a right angle, 180 degrees, because it's a straight line, 270 degrees, because it's another right angle, and then back around again at 360 degrees. It's broken into the 4 quadrants, so remember, you basically have those 4 right angles. All right? The terminal side, they call the terminal side is basically the end point. It's the other side of the angle. So for example, what we're going to do is we're going to take a degree measurement and draw it in standard position. This example here would be a good example of something that's maybe about 135 degrees. Okay. I'm just rough guessing now. I'm going to say that this is probably 135 degrees. The reason why I say that is because notice, from here to here is 90, here to here is 90, and then here is about halfway. Well, what's half of 90? 45. That's why I added it in. So as we get into this, if I want to say what do you think a 210 degree angle would look like? What quadrant would it land in? Remember, quadrants go 1, 2, 3, 4. What quadrant would a 210 angle land in? 3. Very good. So if I wanted to draw what a 210 angle would look like for a rough idea, I know that it starts here, it comes around, and it stops somewhere in here. And then I would say that's 210. That's what it means to draw an angle in standard position. Okay. Not too scary? Could you draw an angle that is greater than 360 degrees? Yes. Yeah, you can. Let me show you. I think I have an example of that next year. No? I'll come back to this one. let's say we have, I'm trying to do the math in my head. It's hard. 540 degrees. Okay, 540 degrees. If I draw that in standard position, it starts here. I go all the way around. How many degrees is that then? 360. Add 90, you're at more than 360. Add another 90, I believe you're at 540, aren't you? Yeah, that's it. So that's 540 degrees. It is not 540, it's 360 and 80, 180, right? Yeah. Okay. All you're doing is how many times it takes you to go around to get to it. So you could end up in some different quadrant umpteen times around the circle. Yeah. Yep, always start at that spot. Always, always, always. What do you mean? Here? This is the initial side. Yeah, think of it as the zero. It's the zero. Okay. If I wanted to draw a negative angle, I go the other way. That's it. The only difference between a positive angle and a negative angle, let's say it's negative 80. Say it's negative 80 degrees. Some of you guys think my classroom is negative 80 degrees.
It is. Yeah.
I know, it feels great. If it's negative 80 degrees, yeah, we can't. A negative angle is just a different direction. Well, in geometry you can't have a negative angle. We're not in geometry anymore.
Can you give a real life example?
A real life example of negative angle? No. No, but I can show you how it works. Okay? Hey guys, great question. Can I show a real world example of where you have a negative angle? No. But can I show you how you can get it, something to make sense of it? Yes, and we'll get to that in a little bit. All right? Now, if I have a negative 80 degree angle, what that means, we're still starting at the same initial spot, and I just go the other direction, 80 degrees, about here. That's negative 80. Okay? So, if you have to show which quadrant you're going to wind up being in, this is still going to be a fourth quadrant angle, even though you only went through one quadrant, okay? Because it's still the fourth quadrant no matter what. It means the same thing if it's negative 700 or 720, whatever it may be. Negative just means you go the other direction, you go clockwise. Positive, you go counterclockwise. All right? Not so bad? All right. So try these three examples real quick and see if you can draw them into standard position and then figure out what quadrant. They're going to ask you what quadrant the terminal side ends in. Basically, remember, that means what quadrant did you stop in. Okay? For that last example, at negative 80, I stopped in quadrant 4. The first example, we stopped in quadrant 2, and so on. So that's what it means by the terminal side. Okay? So try and draw those three real quick. As you go with 210, you start here. What quadrant do you end up in? 3. Very good. Are you using Roman numerals? Use Roman numerals. It's like the only time you use Roman numerals. You only have to know 4 of them. I'm kidding. I do have a question for you. Let's say you wind up and you're graphing at an angle in standard position. What happens if you end up on an axis? Are you in a quadrant then? No. If you wind up at one of the 90 degrees, 90, 180, 270, one of those guys, 360, you are not in a quadrant. You're on an axis, okay? You're not in a quadrant, just so you remember that.
Would you write axis?
Yeah, just write the y-axis or the x-axis. Okay. Negative 45, I'm assuming it will look like this. And it's quadrant 4. And then 510, lastly. 510 means we go around 360. Is it here-ish? So that's quadrant 3. I'm sorry, quadrant 2. Okay. Not so bad? And the devil likes to have a full moon. So, to go back with what Kelsey was asking about, what's the practicality of having the negative 45-degree angle? Well, what happens here is that you actually have what are called coterminal angles. Coterminal angles are angles that share. Sure, I'm still recording. Coterminal angles. Angles, I didn't really draw this one out here. If we had that 510-degree angle, what little thing? I'm not going to yell at you if you don't. If you look at that, 510 and 150 degrees are what you call coterminal. Basically, that means that there are two angles that are in the standard position if their terminal sides coincide, which means they have the same terminal spot. Okay. Any coterminal angle can be found by adding or subtracting multiples of 360 degrees. Now, what happens here, if you think about the negative 45-degree angle that we had earlier, a coterminal angle to that would be, well, start from that spot, go the other direction 360 degrees. If you add 360 to 45, what do you have? 315. So what happens here, that negative 45-degree angle has a coterminal positive angle at 315. So you might not use that negative angle, but you'll use its positive counterpart. It just says you're just going the other direction. That's all. Okay? So you can find coterminal angles by adding or subtracting multiples of 360 degrees. What you're doing here is just trying to find a positive or a negative coterminal angle. With that negative 45 degrees, by adding 360 degrees to it, we found the coterminal angle, a positive. If I wanted to find another negative version of that, I would just have to subtract an additional 360 degrees. Yes. Unless, there's always an unless, right? Unless the angle, when you are subtracting 360 degrees, doesn't give you a negative yet. Let me show you. For example.
So like, if it's like, if the angle's really, like if the angle's like 500 and
Yeah.
minus.
Correct. Yeah, just like this, how it's 495 degrees. If I wanted to find the coterminal angle for 495 degrees, well, see, 495 degrees goes around, there's 360, 540 is always, so it's in here somewhere, okay? It's somewhere in that second quadrant, right? Now, what? Okay. Now, if I subtract 360 from that, I'm still not negative. I have to go again. That's what you're looking at. So all you're doing here from 495, once you subtract 360, you're at 135. Well, subtract another 360 to get the negative coterminal angle. And that's how that works. Okay? Positive and negative. You'll always have one positive and one negative. Okay? So the positive coterminal angle would have been 360 more than that. Okay? That's how you're looking. You always want to go forward and backwards. Yeah. It's not something that you're going to see all that often, You know, it's not there really isn't much of a practical use for it. It's just showing you that you can make more than one angle from one position. More than one angle shares the same spot. Okay. For example, why don't all 4 of you girls stand up? Because you guys like to do things for me anyway. The 4 of you stand up. We'll make an example of coterminality. I don't even think coterminality is a real word. Now, I want one of you to turn around 360 degrees, the other person 720, the other person 900, and then the other person goes. Basically, you're spinning around. One person goes around once, twice, 3 times. 4 times. Well, 3 of you know how to count. Yes.
Okay.
You all fall over it.
I want 4. Ready? Go. What are they supposed to do?
Are you all facing the same spot? Okay, you are all a coterminal angle. Merry Christmas. I was trying to see if anyone would fall over to tell you the truth, but it didn't work. That was a bad example, but all right. So now let's get to the fun stuff. No, there's more, but wait, there's more. Not only not only in math, there are degrees. Everything else can be written in terms of pi. When you think about finding the circumference of a circle, do you guys remember the formula for the circumference of a circle? That would be area. 2 pi r. So basically 2 pi r is the circumference of a circle. Remember, the circumference is the distance around a circle. Remember that? So when you're talking about the distance around a circle, if I'm looking at the distance around a circle, as I start from here and I go all around, that's basically 2 pi. All right? So you start at 0 and you work your way around to 2 pi. Yes. Now, if going around one full rotation is 2 pi, what's going halfway?
4.
Pi. Okay. If it takes you 2 pi to get all the way around, to go halfway, it's just pi. To go 1/4 of the way would be half of pi. Pi over 2. To go 3/4 of the way would be halfway between pi and 2 pi. 1.5 pi, which we write as 3 pi over 2. 2 times around would be 4 pi, right? Oh, okay, all right. Yes, you are right. If you go around twice, you're 4 pi. Okay. So what happens here, ladies and gentlemen, is that you are able to stay away from 90 degrees, 180, 270, 360 by converting them into terms of pi. Now, each one of the important angles, remember we talked about important angles yesterday, 30, 60, 90s, and the 45s? Each one of those has a position on the unit circle. And I kind of showed that a little bit to you yesterday with our awesome chart behind Jordan there. Now, what I want to do today is talk about how you convert degrees into radians, and then how you convert radians into degrees. It's a very simple algebraic step to do, and you should be able to see how it works rather easily. Okay? And then we will talk about how we write out all the different angles in terms of pi. Very straightforward if you follow the pattern. Oops. So, in order to tell, screwing everything up, to rewrite degrees to radians, degree Degrees to radians. Remember, your calculators will not do the conversion for you. You cannot type in 45 and hit rad and then all of a sudden it's going to spit out pi over 4. It won't do that. You need to know how to write out the conversion. Basically what you do is you take the degree measurement, whatever it is, times pi over 180. Okay. So if your degree measurement happened to be, we'll come back to these examples here. If your degree measurement was If your degree measurement was 45 degrees, it's right here. It's in blue. 45 over 180, and slap a pi next to it. Now, your calculator can do that fraction simplifying for you, if you remember how to press the buttons the right way. Just 45 divided by 180, math, enter, enter. It will show you the fraction. I believe you get 1/4, correct? So that means 45 degrees in terms of radians is pi over 4. Okay. And then to go the other direction, to go from radians to degrees, well, you take the value in radians, you multiply it by 180, over pi. Oh, it could be three halves. It could be a fraction. Yeah, exactly. Yeah. So you have multiple ways of doing that. So now, if I want to go the other direction, if I wanted to figure out what, I'm going to make this easy here, pi over 6. Let's say the radians is pi over 6, and I wanted to figure out how many degrees that is. I multiply it by 180 over pi. One thing you will notice is that your degree measurements will never have pi in them, but your radian measures always will. So if you are converting back and forth, you want to make sure that those drop out. And then you wind up with 180 divided by 6. So that gives you 30 degrees.
Where did you get that 6?
I just made it up.
Oh.
I just made up an example. This was just a quick example that I thought of that would show the work rather simply. That's all. Okay. So if I'm looking at these examples here, where it is converting 110 degrees into radians, if I want to convert 110 degrees into radians, I take the degree measurements over 180, and I slap a pi next to it. And once again, in this instance, you'll notice that the fraction simplifies rather quickly. It simplifies out, you just get 11 over 18 pi.
Would you write it like 11 pi over 18?
That's fine. Well, however, either way is fine. Either way is fine. Okay? You guys can write it as 11 pi over 18, or if you want to write 11 18 times pi. Either one of them is fine. It means the exact same thing to me. Right? Same thing going back from radians to degrees. You follow the same pattern. You have negative pi over 9. To convert that to degrees, you multiply it by 180 over pi. Your pi's drop out, and you wind up with negative 180 divided by 9. Negative 20. So a lot of times, the fraction work here is really, really, really easy. Okay?
Is that times 80?
Times. So, the reason that I want to make sure that we get at least this far today to converting back and forth is because it becomes really, 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 really important to be able to do this. Let's shrink that a little. It becomes extremely important to be able to do this. This is called the unit circle. What's that? I can't hear you. No. What I'm giving you guys right now, is just, oh, running with fives. I'm missing it. I am. Oh, no, I'm not. I haven't thrown it. Anyway, here's what I would like to do. What I would like to do right now is spend a couple of minutes with you guys showing you how or what all these angles are so that we can have them in your notes and keep this with you, because this is what the rest of trigonometry is really kind of based off of. All right? There are going to be many ways. You know what? So, here's what I'd like. As we go through this, a few of the angles that I would like to start out with. Well, 0, 90, 180, 270, and 360. Okay, thanks. Now, as you go through this, think about the angles that we talk about that are really, really, really important. What are the three really, really, really important angles that I might already have on the board? 30, 60, and the 45. So there's three angles here. 1, 2, and 3. Which one do you think is the 30-degree angle? The smallest one. Then what? Well, 35 comes after 30, yeah. Okay. Now going this way. As you're coming across between the 90 and this angle, do you think you're adding 30 degrees, adding 60 degrees, or adding 45 degrees? Adding 30. So you have 120, 135, and then 150. Okay? Coming back around. What is 30 degrees more than 180? So it's 210. 15 degrees more is 225. And then another 15 degrees is 240. Okay. 30 degrees more than 270. 300. 315. And 330. Okay? Not so bad. Now, let's discuss how you convert all of those to radians. Now, we have all of the degree measurements right now. And what I'd like to do is convert all of them also into radians. Remember, to go from degrees to radians, you take degrees times pi over 180. So basically, you're taking each one of these degrees, divide it by 180, slap a pi next to it. Okay? So, you guys do the first two quadrants. You guys do the third and fourth quadrants, and we'll check them here in a second. All right? 0 is just 0, because you multiply 0 times pi over 180, you still get 0. Okay? So you guys do the third and fourth quadrants. You guys do the first two quadrants. We'll come back in a second, and then we'll write in all of our radian measures for the unit circle. Usually when you do the radians, if you put all your degrees on the outside, put the radians on the inside. So like right here would have been pi over 6 and so on and so forth. Okay? Cause this is too much more. Now, in the essence of time here, I'm going to start asking you guys what you got, and we'll just keep going along here. 45, did you get pi over 4? Then pi over 3? Pi over 2? Now what? 2 pi over 3? 3 pi over 4? 5 pi over 6? Pi. You alright, Trey? You got a scrunchy face for a second. 210. 7 pi over 6? 5 pi over 4? 240 gives me 4 pi over 3. And then this is 3 pi over 2. And at 300 degrees, you get 5 pi over 3. 315. 7 pi over 4. And then 330. And then last but not least is 2 pi. So what's going to happen here is we use the unit circle. Take a minute or two, bless you, take a minute or two, make sure that you have all of the correct values. One of the other things I hope you might recognize is as you're going between the 30 degrees, 30 plus 30, plus 30, plus 30, plus 30, plus 30, plus 30, all the way around, you'll notice that each time it goes up by a sixth. And just slap pi next to it. If this is pi over 6, 1/6. Pi over 3 is 2/6. Pi over 2 is 3/6. Here's 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So if you remember the trick with the unit circle, as you're going up by 30 degrees, 30, 60, 90, 120, 150, 180, each time you're going up by 1/6. Okay? And then just simplify the fraction. It's a very easy way to remember your unit circle. In the pi over 4, the 45 degree angles, each time you're going up by a fourth. 1/4, 2/4, 3/4, 4/4, all the way around to the 45s. It's a nice trick to know how to do that. So I know I'm going to leave this a little short as far as what I'd like you guys to attempt for homework for the weekend. Don't lose your unit circle. But what I'd like you to do, we didn't get to the sector, which is fine. So let's see where we'll stop at. Can I steal your book? Right. Yeah, I'm sorry. I thought she has a book.
I have my book this week.
Whatever. Give me a grief. Can't I do that? Here's what I would like you to do. On 780, oops. $28 to 58 evens. Okay? 28 to 58 evens. You'll have some drawings, some angles, find some coterminals, convert radians to degrees, and convert degrees to radians. All right?